Hello, thanks for clicking. Welcome to another Nargilus 2 production. Today we're going to be talking about Taylor and Maclaurin series. Okay, this is really the culmination of everything that we've done here in this unit. All right, from your series tests to everything all the way up the board, up the line. Okay, we're going to be talking about how to take Taylor and Maclaurin polynomials and turn them into Taylor and Maclaurin series. All right, so it's not as difficult as it looks. So again, we already know some stuff about Taylor and Maclaurin. We know that the nth term Taylor polynomial centered at x equals c is given by this equation, right? F of c, f prime of c, x minus c, f double prime of c over 2 factorial x minus c squared. We can go on forever. Okay, that would be your nth term Taylor polynomial. And then if c equals 0, we call that polynomial Maclaurin polynomial. And we'd have f of 0, f prime of 0 x, plus f double prime of 0, 2 factorial x squared. And we can go on forever up until the nth term. But how do we take these polynomials and turn them into series? All right, especially if we want to turn it into an infinite series. Well, we can do that too. Okay, so to do that, we would write a Taylor series centered at C, and we can do that. The Taylor series centered at C is given by f of c plus f prime of c x minus c, f double prime of c over 2 factorial x minus c squared, plus, well, you can go as far as you want, okay, and on forever. All right? So this would be the general term for your Taylor series, okay? That would be your general term. All right. And again, you could do the same thing for a Maclaurin series as well, centered at x equals 0, except in place of c, you would just put 0 for every term, as well as the general term. Okay? So your Taylor series would be the sum from n equals 0 to infinity, nth derivative of f evaluated at c over n factorial x minus c to the n. Now, how do we take functions and write them as a Taylor series? So there are three important Taylor series that you have to know. These three you'd have to know off the top of your head. All right? E to the x, sine x, and cosine x. So all of these series we can get or derive from their Taylor polynomials. You actually did this series for sine x. We actually did it in a previous video when we talked about the derivative and the integral of a power series. Okay? But let's show you that it works for e to the x. So let's say I wanted to write the Maclaurin polynomial for e to the x, right? So the Maclaurin polynomial for e to the x, well, how would I write it if I write it out with the form first? So we have f of 0, f prime of 0x, f double prime of 0 over 2 factorial x squared. Okay, that would be my Maclaurin polynomial. That would be what it would look. We'll go out to the third term anyway. They do that here also. So 3 factorial x cubed. All right, so we have to find some values to do that, right? F of 0. F of 0. Well, f of x is e to the x. I know that. E to the 0, that's 1. F prime of x, now, again, we can do this forever, right? Each derivative is going to be e to the x. You just get the same thing back again. So f prime of 0 is 1. F double prime of 0 is 1. F triple prime of 0 is 1. So that means my Maclaurin polynomial would be 1 plus 1x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed. Now, your goal here would be to take these terms and write these terms with a general term. Okay, and we can in fact do that by using x to the n over n factorial. You can see it, right? If n equals 0, you get 1. If n equals 1, you get x over 1 factorial. N equals 2, you get x squared over 2 factorial. N equals 3, x cubed over 3 factorial, right? That's the general term for e to the x, okay? So sine x and cosine x can be developed the same way. Again, sine x we developed in a previous video. All right, you can go back and check that out if you want, okay? But cosine x we haven't looked at, but we did allude to it in that previous video as well, because if f of x is equal to sine x, f prime of x would be cosine x. So the derivative of this series gives me that series. So you don't technically have to know sine x and cosine x. If you know the series for sine x and you derive the terms and the general term, you will get the terms and the general term for cosine x. Okay? So you don't have to technically know all three. But these top two you really should know off the top of your head. All right, now we're going to take these series and we're going to apply them to other functions that are similar to the ones you see. So let's write a power series for the function f centered at c equals 0 if the function is e to the x minus 1. Well, here's the idea. What we want you to understand is that e to the x is this series. 2 factorial plus x cubed over 3 factorial plus x to the n over n factorial. Over n factorial. Okay? The function and the series are interchangeable. So if I want a function for e to the x minus 1, in place of e to the x, I can write all of these terms. Okay? I can write them there. So then f of x would be 1 plus x squared over 2 factorial plus x cubed over 3 factorial, x to the n over n factorial minus 1. So the minus 1's cancel. So f of x is just x plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the n over n factorial. That's what f of x is. F of x is this series. Okay? It's these terms and this series. All right? That's what I need you to understand. The function and the series are interchangeable. Okay? You can literally swap out the function e to the x and put its series terms in its place. All right? Okay, let's try f of x equals x times sine x, centered at c equals 0. Well, I know what the series for sine x looks like. It's x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7 over 7 factorial, negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. So I want x sine x. So what do I want to do? I want to take x and multiply it by the terms in this series. So I want to take x and multiply by x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. Well, we can do that. Just multiply. So then f of x would be x squared minus x to the 4th over 3 factorial plus x to the 6th over 5 factorial minus x to the 8th over 7 factorial, right? I'm just distributing x to everybody. Plus negative 1 to the n. I'm going to multiply x by this. I'm going to add one more power onto this power. That's x to the 2n plus 2 over 2n plus 1 factorial. So the series then is negative 1 to the n, x to the 2n plus 2 over 2n plus 1 factorial. And these are some terms of that series. Okay? And that's it. That's what we need you to be able to do. Take a series, okay, which is representative of some function, and write the series for a new function by making the terms and the series interchangeable. As always, thanks for clicking.